Blazor Architecture, a special user group presentation.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. And I'm doing a ton of online user group speaking, and if you run a .NET or Azure-related user group, I'd love to give a presentation for you. Our sponsor today, ClearMeasure, makes this podcast happen. They are a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. And so if they can help, please get in touch. And also be sure to check out the new video show, Architect Tips. And today, we are going to show a presentation on Blazor Architecture Patterns. And I recently spoke to the NOP Commerce Global Group, user group, and it was a lot of fun, and I knew that this audience would probably benefit from the information. So let's roll it. So today's talk is going to be on Blazor Architecture Patterns, and with an audience of .NET developers and people who make use of all aspects of the Microsoft platform. This is one of the new frameworks that is got a lot to offer. It's very interesting, brings a lot of things together, and there's a lot of content already out there. I agree with the superbness of the Blazor Train series that Carl Franklin has put out. Even some of the developers on my team, I've directed them to that, and look forward to sponsored by Dev Express, and I think they're over 30 something episodes. And there's a lot of other content out there. The component vendors are all getting on board with Blazor components, and there's just a ton of training, developer guidance out there. But what I wanted to put together is a architectural look at Blazor, and not reproduce all of the other developer tutorials and how-tos, but really look at how the architecture works and get you in a frame of mind so that you're thinking about Blazor in the appropriate way, so that when you choose to make use of it in its various forms, that you can make the appropriate choice for your situation. And looks like we have a great group here on this on this meetup, so that's great. A little bit about me. I've been a Microsoft MVP since 2006. My latest book is .NET DevOps for Azure, and I also am a host of a podcast. I like dirt bike riding and kind of do amateur dirt bike on the enduro circuit. My kids do also, and so that's kind of fun. Live about an hour west of Austin, Texas, kind of out in the hill country, and we put out a new video podcast called Architect Tips, and you can check that out. Architect Tips. Just do a search, and I'll talk about some other resources as we go along. Today, as we go through the patterns that I think are appropriate for every Blazor architect to consider. We'll look at how the different flavors of Blazor operate at the architectural level. We'll talk about how they handle memory management. We're going to talk about the high-level hub and spoke architecture and how it can apply to a Blazor application. We'll talk about eventing throughout the user interface. Now, we have a stateful user interface in Blazor, which is different from other page-based web applications. And we're also going to talk about how to test Blazor applications. And it's so important. Don't leave any part of your application untested. And then we're going to talk about some of the unique things that you need to do when monitoring a Blazor application when it's running in production. All right. As we go along, one of the things that I've worked out with my publisher for the book .NET DevOps for Azure is I can give away individual electronic copies of the book. So if you would like an electronic copy of .NET DevOps for Azure, send me an email, jeffrey@clear-measure.com, and I'd be happy to get you an electronic copy of the book. Just send me an email, and I'll make sure you get it. You can also get a print book online, pretty much anywhere books are sold. Another resource you might be interested in is the Azure DevOps Podcast. I'm the host for that, and we've been going for 2.5 years, I think now. And so that's been going strong. And a few episodes back, I interviewed Scott Hunter on the latest in .NET, and lots of people from other Microsoft teams, Stefan Shakow, who works on Azure App Service, and just a ton of other people who are sharing some good wisdom there on the show. And you can find it pretty much in every podcast directory. All right, so let's get our bearings here when it comes to the architecture of Blazor and the process for developing, testing, packaging, deploying, and ultimately releasing a Blazor application. So regardless of how we put together our Visual Studio solution and all the code and the bits and the bytes, every development team needs what the modern term now is a DevOps environment. Okay, now DevOps was the term. It was first used now 10 years ago, so there's probably not a developer out there now who doesn't really, doesn't have experience hearing the word DevOps. But at a high level, when you think about architecture of any application, one of the views of architecture needs to be development process, regardless of what we choose the structure to be of the application that we're going to build. We need to choose the process by which it's going to be built. And so that's the DevOps process, or you can call it the DevOps pipeline when you get it automated. And we have a 2-foot by 3-foot high resolution DevOps architecture poster. If you'd like the high resolution copy of that, just send me an email. I can get that to you as well. But we're looking at the top third of it, and it goes at a high level where there's something unique about a Blazor application in the process. There is something unique in how we organize the source control. We're going to talk about that. Triggering private builds and integration builds, those are largely the same as any other .NET application. There's a little bit unique in the way we package the application, and then there's some unique things in the way we deploy to the 3 distinct types of environments. And every DevOps environment is going to have at least 3 environments, because there are 3 unique types of environments, and you need at least one of each. And we have production environments, we have manual test environments, and then we have test automation environments. We call the test automation environment our TDD environment. But you could have many of each. There's a lot of teams that have multiple manual test environments. You call them dev, test, sit, staging, DIT. I mean, there's so many names for an environment where a human would go in and check something and then either do a bug report or give it the thumbs up and pass it along. But that's kind of the overview. That's the lens that I look at it. This is the complete poster that I'm not going to go into, but you just send me an email if some of you are interested. Happy to send that to you. But let's talk about the first step. Let's talk about version control. So any software system can be broken up into multiple applications, and largely today the Git version control system has won the version control battles. We're all using Git now. We're not using Mercurial anymore. We're not using Perforce. We're not using TFVC. We're not using Subversion or the really old Visual Source Safe or SourceGear Vault. Largely, if you're doing something new, you're putting it on Git. It's important that one Git repository have one and only one versioned software application. Now, I'm talking as a logical construct. In Visual Studio, that would most of the time be a single Visual Studio solution. Okay, that is one versioned software application. Now, it is perfectly fine for one software application to have multiple deployed processes. For instance, one application could have a web application. It could have a web API web application. It could have a little WinForms tool in it. It could have a console app. It could have a few offline jobs, and it could have a SQL Server database. And that could all be in one Visual Studio solution, but that's still one version software application. So whatever that unit is and whatever boundaries you put around it, that goes in one Git repository. If you want to have a second application and it's going to have a different versioning schedule, then it needs to be in a separate Git repository. You don't want to make up a directory structure and then put two source trees in the same Git repository. Git wasn't designed for that. And every tool that operates downstream in a DevOps environment is built and tested with the assumption that we're going to build and test everything that's in the Git repository. And so if you are not conforming to that convention, then you're going to be rolling a lot of your own script and kind of fighting against all the products in the ecosystem. Really doesn't matter which one. So Blazor is a .NET 5 application. So Blazor does not need to be its own Visual Studio solution. It can be a project in an existing Visual Studio solution, and you create a new Blazor web application, regardless if it's Blazor Server-Side or Blazor WebAssembly. You can put that in an existing .NET Core 3.1 solution, .NET 5 solution, and of course, later on this fall, whenever it comes out, .NET 6. All right, so that's source control. Now, I want to talk about specifically how the Blazor server-side architecture works. When you have a web application that is powered by Blazor Server-Side, and I'm going to go to WebAssembly next, you launch the application via a URL, and what comes over in the browser is a JavaScript file. Okay, you're in the web server, and all of this, I'm assuming that this is going to be deployed to Azure. Azure App Service is really the go-to for hosting these things. You could run it on your own IIS server. It's just a .NET application, but there's so much to be gained by putting it into Azure App Service. But the JavaScript client is going to go over to the browser first. Okay, then the JavaScript client is going to immediately open up a WebSocket back to the web server and communicate via SignalR, the SignalR synchronous messaging framework, all of the different things that need to be communicated. The first thing to be communicated is, what's my initial screen? And then the server is going to send messages, and that JavaScript client that's running in the browser is going to dynamically load HTML elements, or it's going to insert frames, as they're called, into the DOM so that new HTML elements pop up on the screen. Okay, there's not a time where Blazor server-side is streaming HTML as an HTTP response. The HTTP response is the JavaScript file, and then all communication goes back and forth. So none of the code that we actually write gets sent over to the browser unless you were to inject some JavaScript. What runs in the browser was written by Microsoft, and it's JavaScript. That's how all of Blazor is C# on the server side, because it runs on the server. All right. Before I go to WebAssembly, let me show you what you might find if you go to the network tab of the developer tools. Just hit F12 in Edge or Chrome and go to the network tab, go to messages, and you're going to see when you select that WebSocket, you're going to see a lot of really small binary messages going back and forth. And you can see some of them are really small, 3 bytes, 540 bytes. A few of them are kilobytes. And if you click on some of them, most of them are not going to make any sense to you. But then we can see on one of them, on render completed. Oh, well, that sounds like a .NET method in one of the Blazor components. And it is, because every one of those lifecycle stages in C#, those end up being round trips back and forth from the browser to the server. So as we're looking at this, we're thinking, okay, there is a lot of round trips happening, even for a single page, even for painting a single screen. There's going to be probably half a dozen or a dozen round trips to the server. So latency in your network topology becomes important. Now, from a practical standpoint, we've seen these applications be out in the wild, and they are super, super fast, because once a screen makes its way to the DOM in the browser, that HTML doesn't have to change until it needs to change. So there's actually less bandwidth being used in this fashion than if you were to do the same screens with ASP.NET MVC, for example, where every click, every change was a full round trip to the server and repainting the screen. Okay, it's kind of like automatically using AJAX or callbacks, and the reason is because these messages are so tiny. However, if you are in an area where network jitter is just really bad or latency is just really bad, this could impact you. Okay, but at the same time, if you have a network that's really bad, it's even more important to have a stateful user interface, which this is. Okay. Now, before I leave this, Microsoft is working on a better visualizer for the contents of these messages. And so I've heard that they are working on that visualizer in the Microsoft Edge Canary builds. So if you're interested in that, you can go and check out the latest builds of the Microsoft Edge browser and see what the state is of the visualizer of these messages. All right, as we're running this in Azure, there's a few settings that are really important to get right in order for a Blazor server-side app to work properly. The .NET Framework version is totally irrelevant in Azure App Service for a Blazor server-side application. However, the platform is very important. By default, if you start off testing with one of the free tiers of app service, then the free versions don't support 64-bit. They only support 32-bit. And so you're going to get 32-bit by default. If you then later upsize your app service and say, oh, let's actually use this environment, let's make it production, then you're going to run out of memory fast. You're going to wonder why all the memory that's available on those servers is not being used. It's because you're set to 32-bit. So you want to make sure that you switch it to 64-bit. Blazor server-side takes all the memory of every user that's using the application, and it stores it on the server. So by definition, you are going to be using more CPU power, more memory consumption with Blazor server-side, and that's the trade-off. Talk about WebAssembly in a minute. I'll go down to the bottom radio buttons. WebSockets is another thing you need to turn on. You need to make sure that is on. If not, then SignalR is going to fall back to long polling and is going to generate a lot of extra traffic to your server. It's just going to waste your CPU time because it's not going to be able to actually have a WebSocket connection that's back there so that the server can reach out to the client. The SignalR on the client is going to be constantly reaching back to the server saying, hey, is there another message? Hey, is there another message? Now, once you get past initial development and you get further on, I would advise you to split off the SignalR into Azure SignalR service and get the SignalR processing out of the app service altogether. Azure's SignalR service works phenomenally well, and it's going to allow you to scale up, support a web farm scenario. If you don't use Azure SignalR service, then when you scale up from Azure App Service to 2 instances, and then you have some SignalR messaging going on, only the clients of the originating web server are going to receive the SignalR messages. So if you add some additional SignalR hubs, and you want to do some messaging to all of the connected users, and you've scaled up to 2 instances in the app service, you need to use SignalR service so that every instance, every app service instance is on the same SignalR hub. Okay. Now, if you're not using SignalR for anything additional and all you're doing is leaving it and letting Blazor use its SignalR under the covers, just the built-in part, then the Azure SignalR service doesn't matter, except for performance. You can save CPU, save a lot of CPU and round trips doing that. The ARR affinity, you are going to want to turn that on because Blazor Server-Side keeps the user state on the server, and if the user is routed subsequently to a different web server, then they're going to get a fresh circuit from scratch. Circuits are the behind-the-scenes Blazor user sessions, and it's basically the persistent connection. Okay, now Blazor WebAssembly, all of the memory and all of the CPU of your .NET code is on the client. It's actually running inside the browser, and it is calling back to the server via web service or whatever you want to call back to. You can call, you can basically do any callback that you could with any other browser application. So if you've done some work with React or JSON or just any kind of JavaScript, you can do anything that you can in JavaScript with Blazor. Blazor runs in the same security sandbox that any other JavaScript code runs in. So you can't reach out and get to the operating system directly. You can't do a lot of things because it's running in the same sandbox that any other JavaScript code would, or any other code running in the browser would run in. So Blazor doesn't give you additional capabilities that you couldn't do with JavaScript, but at the same time, all the same limitations of JavaScript, they are limitations on Blazor because they're running in the browser security sandbox. So the trade-off, the difference between whether to choose WebAssembly or server-side is a trade-off of horsepower and productivity. If you want to, if you want to have your user's CPU and memory be used for the processing, well, that's WebAssembly. But there's just a little bit more development because you have one more layer. You do the user interface in C# and HTML and CSS. It runs in the browser, but then you need to do a network hop for web service calls over to the server to get data and to do transactions. So a little bit more development. If you want to optimize for developer productivity and eliminate that layer, then that would push you towards Blazor Server-Side. And then the trade-off there is that you are going to pay for the CPU and the memory for the processing of all of the user sessions. So that explicitly is the trade-off. Those are the decisions. If you don't care about paying for the CPU and the memory, and you want the fastest developer productivity, Blazor Server-Side all the way. If you really want to be efficient in the processing, you want your Azure build to be really, 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 really cheap, and you can add that additional network hop, that additional layer, then Blazor WebAssembly is your decision. Now, what's on the screen now is a candidate Visual Studio solution structure. Now, this is an actual real application, and it's in the auction space, and you can see that there are two web applications. One is called UI and one's called UI.admin. So think about this as an auction site that's public, and then another auction site that is only available to the auction administrators for changing things, doing things on the back end. So there's actually two Blazor applications in this Visual Studio structure, and it also uses the conventions of Onion architecture. I'm not going to go into that now, but just do a Google search for Onion architecture, and you can read the material about that. But in short, the diagram on the left shows the directionality of the dependencies, and with regular layered architecture, all the arrows would eventually terminate through your data access and terminate into your database. Whereas with Onion architecture, all of the dependencies terminate into your core and central library, which has hardly any dependencies, is a .NET standard. It's not even a .NET Core, .NET 5. It is a .NET standard library, does not have hardly any NuGet packages that it depends on. And we try to push as much code into that library as possible, thereby keeping adapter code and code that is tied to APIs of libraries off to the side, so that when those libraries change, it doesn't have a destabilizing effect on a lot of code. It just has a destabilizing effect on just the code that wraps it up and adapts it. Okay. So let's go into memory management a little bit. There's a few gotchas that anyone putting their first Blazor application into production, they're gonna find these out. And this is actually relevant to regardless of its Blazor WebAssembly or Blazor Server-Side. Now, the first is the services collection, dependency management, the built-in IOC container. My favorite IOC container for .NET 5 is a library called Lamar. It's put out by Jeremy Miller, and it is the .NET Core successor to the venerable structure map IOC container that's been around since .NET 1.0, and probably, in my view of it, kind of made IOC containers popular in the .NET space. But there are 3 different scopes in the services collection, and they are singleton, scoped, and transient. Now, back before IOC containers were really popular, or when they first started taking hold, there was only singleton and transient. And singleton meant, hey, when I ask for this particular type, I want you to give me the same object regardless of how many times I ask for the life of the process. Transient meant every time I ask for this type, I want you to give me a newly constructed object. When web applications became so popular around .NET 2 timeframe, I mean they were really popular, but as far as with IOC containers, there was a need. Singleton didn't quite work, and transient didn't work. There was a need to get the same instance of the type for the life of the web request. And so scoped or hybrid, it originally was called hybrid, and now it's called scoped. Now that came about. And so the scope, it became the life of a web request. So for the life of a web request, I want a singleton, as opposed to singleton for the life of a process. Okay. Now, with web requests, where we have page-based web applications, this makes a lot of sense. However, let's look at it with Blazor. All right, Blazor server-side. There is one web request, the JavaScript client comes on, and then the JavaScript connects back with a WebSocket, but never actually completes the web request. Okay? So there is one web request for the life of that user's session. So scoped in the Blazor server-side sense doesn't mean, well, it doesn't, because it means the life of the web request, it could last hours, however long that browser tab is connected via that WebSocket. So for a user session, that effectively becomes a singleton. Okay. Now, a lot of times if we mean singleton, it's for the whole server for all of the users now. And in Blazor, now scoped means per user because of the way it works, and transient is every time. For Blazor WebAssembly, because there is a different Blazor process running in the browser for every user, singleton and scoped are exactly the same thing. Because scoped is for the life of the web request, which in this case is the same scope as the life of the process. So scoped and singleton are going to have the same behavior in WebAssembly. And I'm going to talk next about a little bit of difficulty that has. Now, with Blazor Server-Side, the server is keeping track of sessions. Now, Blazor calls them circuits. And so when a browser disconnects and then reconnects, Blazor reconnects them to the same memory on the server side. And so there is a such thing as abandoned sessions. And so there's a 3-minute timeout. Now, whether you're looking at the Blazor application via a browser on your smartphone or any Wi-Fi, these networks are not perfect. They cut out, they come back in, and that is normal. So Blazor is not immediately going to garbage collect all the memory that a user session has. It's going to give it a grace period of 3 minutes to see if that user comes back. And that's the connection in Blazor is called a circuit. And if you were to completely refresh the browser, it's going to dump whatever you had and create a brand new circuit or a brand new session. And so there's this concept of disconnected circuits and open circuits. And we'll talk more about that in the monitoring section. But just know that there is a 3-minute timeout. You can, in configuration, change that timeout. But if you use a lot of memory and you immediately close the browser tab and you wonder why that memory isn't being cleaned up, it's because a 3-minute clock has started. And if you come back, if your network connection just comes back, you didn't close the browser tab, but just the connection got disrupted, then the framework will reconnect to the same session. All right, let's talk about Entity Framework, because that's really, really popular for Blazor server-side. You literally can get data with this object mapper and get it onto a screen, and it's super fast. But Entity Framework has the guidance for all kinds of ASP.NET web applications to use scoped. And in fact, the helper method up top left, add DB context, under the covers, it's actually using add scoped. Okay. So what that means is that the same instance of the DB context is going to be used for every operation for the session of a user. Now, most of the time, that's not what we want. Okay. So using services.addDBContext is not going to work for Blazor server-side applications or WebAssembly, because think of it, WebAssembly is effectively going to be singleton because it's the life of the user session, which is the life of the process, and WebAssembly in the browser. Okay, so addDB context is not going to work. And in WebAssembly, obviously, you wouldn't be calling out to Azure SQL, but you might be calling out to other data stores that Entity Framework supports running directly in the browser. But either way, addDB context is not going to work. So Microsoft, they realize this. They've come out with some guidance and some documentation on how to add a layer of indirection with an explicit factory. They've even provided the code for a DB context factory, so you don't have to write it, just plug it in. And it kind of looks like this, the for of type data context, which in this application is the type that inherits from DB context. That, by the way, that syntax is the Lamar IOC container. It'll be a little bit different for a different IOC container, but that enables your message handlers to and bid query handler. That would be a type that's in your data layer. It can effectively handle the bid query, and it allows those classes to continue to depend directly on whatever your DB context class is, but the IOC container uses a factory under the covers and gives you a new or gives you the same instance of the DB context depending on how you've configured your factory. Okay, in this case, we've configured the factory to be transient, but then the factory has some intelligence in there. And then if we need the code to explicitly be in control, then we can depend on the DB context factory instead of the DB context directly. All right, let's talk about the hub and spoke pattern. The hub and spoke pattern is really a family of patterns, and it's been around for a long time. And basically, every framework uses it. Absolutely, every framework uses it. The hub is an abstraction. Think of it as an interface or an abstract class, and the spokes are all the implementations of the interface. Now, even the route handlers, when a URL comes in, the .NET framework needs to figure out where to send that particular URL. Well, the URL comes into one spot, and then there's a lot of spokes for however many routes we've configured. And then it comes into, say, MVC or Blazor. Each of those is a hub. And now it's in MVC, we need to figure out what controller to route it to, spokes. Or if it's in Blazor, what component page to route it to, those are spokes. Okay, so that's the general gist. The hub and spoke pattern is also very similar to CQRS, or CQRS is in many ways uses an implementation of hub and spoke when coupled with a bus. Okay, so CQRS stands for Command Query Response Segregation, where way up in the user interface, a user does something, clicks on a button, types in something, whatever it was. In the user interface, we create an object that encapsulates what the user's intent was. Once we get down into our application, it's really hard to discern what the user was really trying to do. So up in the user interface, it kind of is named user interface with the user. So the user does something. The user interface knows how to interpret that behavior and know what the intent, what the desire of the user was. So we create an object basically with that desire, and then pass the object as a command or a query, and we use those by convention, into the application, and we basically give it to a bus, a class or an interface named something bus. And that's a pattern where you send an object down a bus. Lots of different spokes or lots of different listeners can listen for it and think to themselves, ooh, am I interested in that? Or can I execute that command? Or can I satisfy that query? Okay. And so that's the gist of the pattern.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Now, on the right-hand side is a diagram of how the application or how that bus pattern will be put together. And this is a synchronous application bus, and it has multiple handlers, multiple command handlers, multiple query handlers, each of which may talk to a database, it may talk to an external system through a gateway. Also, interesting aside, this diagram on the right was put together by PlantUML. And there's nothing graphical about this diagram on the right other than how it appears. The source code is just text. And so if you are looking for a way to have design diagrams or architectural diagrams that are versionable and where you can store them with your code base, look at PlantUML and also look at the C4 extensions for PlantUML. Actually, there's a show on the Architect Tips video podcast about this and kind of a demonstration through that. But it's just really great to be able to throw together some text, hit a hotkey, and then this diagram pops up just for clarity. All right. So as we're looking at this bus pattern, which these days I don't write an application without a bus. This is the conduit from the user interface into the application, and we have two main methods on the bus. One is send, one is publish. Send is for commands and queries, meaning, hey, I need that one handler that knows how to satisfy the query, or that one handler that knows how to execute a command with the proper transaction, and it needs a response. The publish is for events, where I need to send around the application that something just happened. And you know what? A lot of different code in the application might care that event happened. And because the event happened, I'm not asking anybody to do anything. And there's no return type. It's a notification. Okay. All right. And under the covers, my favorite library right now under the covers for routing and integration with IOC containers is the MediatR library. Jimmy Bogart has put that out, and I wrap the MediatR library and add some additional logic because it's pretty bare bones. You'll want to wrap it too, just like you wrap every library, and so that you're not accidentally using the library's API language in your application, but you're using your language in your application. That's the best practice for any library that you use. And I understand with some of them, there's a trade-off. If the library has just a massive API surface area, but MediatR has a very small surface area. Actually, here's a funny aside. Control libraries or component libraries from Telerik or DevExpress or Radson, they have pretty large API surface areas, but for all of the common stuff, where if you're gonna use a lot of grids, or if you're gonna use a lot of text boxes, a lot of those things, it can be an effective one-time exercise just to inherit from every one of their controls into classes that you own, and then use your controls that inherit from theirs in your application. Because, and this happens so many times, you use a control vendor's drop-down box or combo box, or even grid, and then something comes along and says, "Oh, I want every grid in my application to do something," or "I want every combo box in my application to, detect accidental all capitals, or text boxes that detect accidental all capitals and do something." Well, if you're using your type, then you have somewhere to put that logic. If you are using somebody else's type everywhere, well, you don't have somewhere to put that logic. So just food for thought. And as you're looking at what type of application you're developing and how many developers are on your team, again, you got the architect hat on. It's not only your job to determine the proper structure of the application and the code base so that it comes out properly, but you need to think about all of the methods that your developers are using so that they are successful in the pace that they deliver this application. Okay, let's give an example of a cross-cutting concern that the bus gives us. Because there's one place that all queries are going to from the Blazor UI, one place that all the commands and events are going through, it makes exporting telemetry absolutely trivial. And this is the first place that we go to for logging, for auditing, for calculation of metrics. And so this code right here is part of the bus class, and it really is just, hey, record call. And what this does is it uses the application insights objects of event telemetry in order to use a little bit of reflection, look at the type of the command or the query or the event, grab the top level properties of it and add those as well, and then send that event telemetry as a custom event to application insights. And we'll see what that enables us to do a little bit later. All right, let's talk about UI eventing up in the user interface. Doesn't matter if you've gone for WebAssembly or server-side. The user interface is stateful, and those screens can be kind of complex. There can be multiple areas of those screens. You got the top, you got the masthead at the top, you've got the side navigation, you got maybe multiple panes, and you've decomposed it down to multiple components. And now something happens in one part of it, and it's useful for the components in other parts of the screen to be notified. You do not want to try to use .NET multicast events for that, or explicit delegates. You do not. You need a loosely coupled eventing pattern, okay? And so if you've done any desktop applications, if you've done any JavaScript SPA applications, some of those patterns are directly applicable here, where the code does not go down into the application. The code stays in the user interface. This is user interface eventing, where one part of the screen notifies the rest of the screen that something happened. Okay, let's look at a particular Blazor component that does this. So this is one of the screens of the car auction application. We're showing details. We kind of collapsed some stuff here. So we're showing details of the car, and you can see the bid dialog at the bottom. But up top, you see a refresh timer. Okay, that's just thrown in there. It's a refresh timer. So let's look at what's inside the refresh timer. Now we're inside the refresh timer component. Notice there's no HTML. There's only C#, and we're initializing a timer. We're getting the configuration for how long the timer is from our app-settings.json. And when it's invoked, all we're doing is sending a refresh timer triggered object, which is an event. It's just an empty class. We're sending it to the bus. Hey, bus.notify, and we're sending it a particular event. All right. Well, let's look at how this gets consumed. Now we're jumping over to we're jumping back to the car details component, a portion of it, and that component implements 4 interfaces, the iListener interface for 4 of the different events that are interesting to it. And one of them is the refresh timer triggered, okay? Because if you're looking at a particular car and you think you want to bid on that car, it's meaningful if somebody else just placed a bid. You want that bid to show up immediately, especially in an auction. The timing is super, super important. So you want to know immediately when it happens. And so there's 2 methods, one of which is just a periodic timer to make sure that we're up to date. And then we'll talk about more real-time eventing next. But notice that the iListener interface causes that component to implement a handle method for each of those event types. And then the component can just call whatever method or do whatever it needs to. All right. And so that's UI eventing. And in that way, if you needed to be able to click on a tree view on the left-hand side, and then a properties pane on the right-hand side shows a particular item, all you would have to do is have a item selected event, and then the property of that class would be either the object or the identifier of the object that was selected. And then every component that's alive, that's on the stack in the rest of the screen would be able to declare iListener of item selected event and know that it happened and be able to trigger. And so that's how you do UI eventing in Blazor. Don't use .NET events. Don't use C# delegates. You'll end up with a spaghetti mess. This is the pattern. And I don't care what you call these things. Call it something else from iListener. It doesn't matter. But this is how you do distributed UI stateful eventing in Blazor. All right, let's look at the interaction, the speed, the performance of Blazor Server-Side when loading a screen that's a little bit long. If you open up your F12 developer tools and go to the performance tab, you can actually record the loading of a screen in Blazor, and you can look at all the different calls to insert frame, and you'll notice that there's quite a lot of them because the JavaScript is receiving data over a WebSocket and then is telling the browser's DOM, document object model, to add frames, which effectively is adding HTML elements. And sometimes when you have a screen where you have to scroll down, that can appear to be slow because the browser is not going to change what visibly appears until it's completely finished with the on message call that you can see at the top. And You can see in mobile applications, in JavaScript SPA applications, a lot of them will load kind of like a fake filler with a little animation before the screen refreshes, and that's just so that you don't think the application's locked up. I'm going to show you a trick that will actually refresh your browser pages in the DOM a lot quicker without having just to show a please wait type animation. All right, let's say we have 100 cars in an auction, and we need to show a tile for each of them, and they're going to have to scroll down. Well, only about 10 of them are visible before you have to scroll and see the rest. So what we can do is we can have a grid or a list, a UI control that shows a kind of a running list of tiles, and that's the underscore items to display. And we can set that collection to the first 10 of the actual 100 cars that we brought back. Then if we call Blazor's state has changed method, that will immediately cause the server to push that over to the browser, and then the browser will take 10, refresh the screen, and that is going to be really, really fast. But this is all asynchronous. So as soon as that fires off to the browser, then we set all 100 items to the same bound property for the grid, and then call state has changed again, and then all the rest of those 100 go over to the browser. So what you'll actually see is the first 10, the screen will load immediately, and then a split second later, you'll see the scroll bar get smaller because all the rest of them have loaded. But from a perception perspective, the screen loads imperceptibly fast. And this works because of the speed of the DOM and the way the browsers work. Okay. So this technique, you'll want to use this technique on server side and WebAssembly, because regardless of what you're doing, you still have to work with the realities that the browser is controlling changes to the DOM. And you can't just do large changes to the DOM instantaneously. The browsers are not instantaneously fast. All right, let's talk about broadcasted events. Now, there's going to be times when you have a lot of users connected and one user does something, and all of the other users need to see that immediately, pretty much in real time. And if you didn't need that to be in real time, you could use asynchronous durable events with Azure Service Bus or Azure Queues or anything else. But let's take the instance of a car auction. There's a lot of people that are watching a particular auction. Multiple people kind of have the same car selected, or the current car where an auctioneer is calling out bids. And it could be facilitated or just online. And if somebody else bids on the car that you're looking at, it'd be kind of a bummer if you didn't see that the price had changed until you refreshed something. So regardless of who's looking at the car, someone makes a bid, we want that price to update immediately. This is how we do something like that. We use the same SignalR capabilities that Blazor comes with, but we just create an additional hub that we control. Whereas Blazor has a SignalR hub under the covers that it is using for its purposes for Blazor's SignalR. If you're using that for WebAssembly, it's not in place. But you'll want to create your own hub. And so we wrap that with a implementation of an interface. We call it I like to call it a broadcaster. You could call it a gateway because it is going out across the network. And the gateway pattern is for wrapping something that does call out across the network. But you're going to encapsulate an iHub context. That's the SignalR type. And then you're going to take your message, which down in the broadcast method, we're going to have as many events, as many notification types as we want that all inherit or implement the iBroadcastable notification interface. And we're going to send those out. Notification.broadcast event, and we're going to send it to a particular group. You can do your grouping however you want. You start out with global grouping. For an auction, it was important that all the events got sent for the people who are looking at the same auction. Because obviously, if there's a car auction on the West Coast, they don't need events from a car auction that's happening on the East Coast. It's a totally different event. The prices are not even gonna matter. Okay, so that's what the groups are for, and you can use whatever you want for the group ID. It's totally up to you. But that's how we send events to all of the different clients through a custom SignalR hub, and then those come through and get routed to the same iListener interface as any other event. All right, so that's how you do broadcasted events across many users of the same application. Let's talk about testing. Yes, you do want to test your Blazor components. Don't think, oh, well, this is HTML. Oh, well, this is kind of weird. I guess we're not going to be able to test it. No, you need to test it. Now, if you are scrolling several times in your Blazor component because there's so much code in there, well, then you've effectively written bad code, and bad code is pretty much impossible to test. Good code is possible to test. So that's kind of a heuristic. But this is a library, and this is a technique for testing Blazor components themselves. The B-Unit framework is the go-to framework. The Blazor team at Microsoft has endorsed it. It's free and open source, but effectively it comes into you can use NUnit, XUnit. It's just a library for being able to set up a individual Blazor component with its parameters, with its dependencies, execute it, cause it to render, and then be able to inspect what it did. And you inspect it with HTML elements because Blazor components have an HTML structure to them. We need to cause them to do what they're going to do, and then make sure that the markup is as we intended. And so you can see the assert statements we're finding, and we can use CSS selectors for this. So we don't have to parse any text. We're making sure that there is an element that has an ID of bid button. Okay. And then we do something else. We run the component again, and we're making sure at the bottom that the bid button is not there because we changed the car, the entry in the auction, to have its block from sale property to be true. And of course, a message at the bottom. All right. Now, for full system acceptance testing, these are the tests that have to run in a fully deployed environment of your application. So that's why we have a TDD environment, our test automation environment, because we need an environment that is automatically deployed after the integration build passes, after we automatically package up our new release candidate, and we automatically deploy to our test automation environment, and then run the suite of full system acceptance tests. Because this is still an HTML-based application, we are going to use Selenium. Now, there is not yet an automatic trigger for when a Blazor operation is finished. So unfortunately, you're going to have to do a little sleeping right now. I think that's going to get resolved. But that's why you see the sleeps there, because Selenium needs a hook for when an operation is complete, so it knows when to keep going. But use Selenium for your full system testing, and make sure that you have finished your continuous integration process. Remember, continuous integration was defined way back in 2006, and it comes with 3 steps. The first is the private build. It's the process that happens on the developer workstation. It answers the question, is this code ready to share with my team, or have I completely broke something? Okay. The next step is the integration build. It's on the Teams server, and it answers the question, this code mixed in with the code of the rest of my team, does this all still work? And do I have or do I have an unstable code base? Okay. And then if that answer is yes, then we move forward. And the third stage is the first deployment. And we do that and then run some tests with Selenium and otherwise. And that answers the question, does this build still deploy properly? Does this build still start up and continue to do what it used to do properly? Or did we just break something. All right. These are the 3 steps to continuous integration. And I found a lot of people say that, they have CI in place but they only have the middle step. They only have a triggered compilation process and, some level of tests. But there are 3 steps to continuous integration, and each is really important. And only when you've done all 3 steps can you have confidence that when you deploy to a manual test environment, that your product management team or other stakeholders aren't going to come back and say, why did you deploy this thing? It's completely broken. And of course, you don't want to have a development team level manual testing process just to get to your manual testing process. You want to have that automated, and that's what continuous integration is for. All right, let's get to operations and monitoring. Now, Blazor is going to use more memory than ASP.NET MVC. But you have 2 choices. You can put that memory on the server side with Blazor Server-Side, or you can put that memory on the client side and split it up per user by doing WebAssembly. On the server side, it's going to use more CPU. And on the server side, you also need low latency. Okay, so I've talked about those. From a telemetry perspective, you're going to do your logging that you're used to. But for Blazor, you want to instrument what people are doing. And it's great to piggyback on the principle I talked about before, which was to encapsulate the intent of the user. Everything that a user does with your application, encapsulate what they did and throw it on the bus as an event. And then if you're automatically capturing all of those things that go through the bus with application insights or Splunk or New Relic or Stackify, whatever you use, then you're going to get a lot of great telemetry for free. Okay. Also, for operating this, just came out in November, and it's not automatic. You have to do something. Version 3 of App Service instances have come out, and for the same price, they're giving you twice the CPU, twice the memory, and introducing reserve instances. If you know that you never go below 1 instance or 2 instances for a whole year, you can reserve those instances, commit to paying for them for the whole year, and get an additional 33% discount off the prices. So if you have not moved to version 3 of the instance types on App Service, then you are paying at least twice as much as you should, and possibly more than twice as much if you can do reserve instances. So hopefully that can be a takeaway for a lot of you. And by the way, that's not even just Blazor applications. That's every application. Okay. So these are the P2 instances, and the new P1 V3 is basically the old P2 V2 specs, but on better hardware. Okay. Let's talk about Blazor monitoring. Server-side data in the server response time and receiving response time is going to look different than WebAssembly, where the server side is essentially web service calls and kind of looks like other web service calls of the past. Blazor server-side stats are going to look different because those messages are so tiny that they get responded to and returned really, really fast. But there's also more of them. So you should expect the server response time to be really, really low. And I'm happy when it stays at 2 milliseconds. You should also expect the receiving response time to be lower than an ASP.NET MVC web application, for example. I get concerned when the receiving response time goes above 100 milliseconds. Okay, just from observing some of these Blazor applications out in the wild. And the first step is to either increase the size of the app service instance or to add an additional app service instance. If you have a lot of circuits connected, and you're going to have to get to know your application to determine how many circuits your application can support before the server response time starts growing. And then if you are connected to a dependency that's kind of slow, for instance, if you saturate your Azure SQL and you need to scale that up, then server response time is going to start going up because it's going to be waiting. Blazor should just automatically be able to scale up with the instance count as long as you have turned on ARR affinity, which is sticky sessions. So you want to make sure to do that. Now, let me show you application insights. I've talked about encapsulating the user's intent and then sending all of these messages to your application performance monitoring tool with custom events. Well, we've done this with Azure Application Insights, and we can see that we've checked some of the events, and we can graph it right there. We have a count of how many events over time, and we can see the cyclical nature of car auctions. They happen towards the end of the week and the weekends, but we can also see the number of usage of this particular application growing throughout last summer. And we basically get all of this telemetry for free. If we wanted to whittle it down and just say, hey, submit new bid command, how many bids are we getting? And then we still want to slice it and dice it by auction. We want to slice it and dice it by car type or division or anything else that we've set up. Well, Application Insights is kind of built for that. We just have to get the telemetry data over to it. And yes, we could create our own custom data center for all this stuff. And I know a lot of you probably have. But if you use these more modern techniques, then you kind of get this stuff for free. The green check mark at the top is markers for when we have deployed to production. And so in our automated deployment script, we have a task for annotating this release with Application Insights. I mentioned that circuits was a big deal for Blazor Server-Side because Blazor kind of keeps connected. You'll want to emit your own custom metric for circuits so that you can know how many circuits are attached. And we can see that there were around 30, and then we went down to 10, and kind of went up to 15. And this was a kind of a test run. Just to get some data, got a snapshot from that. But we have a concept of connected circuits, then open circuits, and then disconnected circuits. Okay, open actually tends to be a little bit higher than connected, and for our purposes, we haven't found any difference. They're kind of the same thing. But for some reason, there's two different things in the Blazor framework. And then the disconnected ones are the ones that have not been cleaned up yet by the framework because they're in their 2-minute timer. You will want to track your own version of each of these things. They're not built-in metrics, but this most closely correlates with how many people are using your application at any given time. You can see that this is split. The view here is split between 4 different web servers, 4 different app service instances. That's why we have 4 lines. And so if you just add it all together, you can have your total for this particular run. You'll want to keep track of this because this is how many people are actively connected. But if somebody has 2 browser tabs open, they might account for 2. Blazor has a class called Circuit Handler, and you gain access to all of this events by inheriting from Circuit Handler, implementing your own logic, sending a custom metric to Application Insights, and just doing some logic there, and then registering your new class with the services collection. So that's the class you hook into in Blazor in order to get events for when someone when a new person logs in, when a new person goes to it, or when someone goes away. All right. I know that is a lot of information, jam-packed. I'll kind of leave this slide open, encouraging you to go to Architect Tips. And also, if you do want a electronic copy of .NET DevOps for Azure, just send me an email, or you can see me on Twitter at Jeffrey Palermo. Thank you. Thank you very much.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.